All right, so we're into chapter 5, and this is going to be 5.1, titled Bisectors of Triangles. Okay, so we're going to be talking specifically about different types of bisectors within a triangle. So the first one that we're going to talk about is called a perpendicular bisector, and it's just easier to start out with the theorem. So we're going to start with the perpendicular bisector theorem. So perpendicular bisector theorem. And it says if a point is on the perpendicular bisector, of a segment, then it is equidistant from the endpoints of the segment. Okay, so we're going to draw a quick picture of that. It said if a point is on the perpendicular bisector of a segment. So we're going to need a segment that we'll call segment AB, and we're going to need a perpendicular bisector of it. So something like this. We'll have a little line going through it. It says if a point is on the perpendicular bisector. So remember, if this is a perpendicular bisector, it means we're perpendicular and we split the thing that gets bisected into two equal parts. So if a point is on the perpendicular bisector, so we'll put this point C up here, then it is equidistant from the endpoints of the segment. So what that's saying is that this distance from C to A and from C to B is the same distance. So if this point is on the perpendicular bisector, then CA equals CB. So what you're looking for in a problem or in a proof or in a picture that you might see is perpendicular, bisected, and then a point that's equidistant from the two endpoints. Now we're going to have the converse of the perpendicular bisector theorem. Okay, it says if a point is equidistant, so now we're starting off like the other one ended. So if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector of the segment. Okay, so if a point is equidistant from the endpoints of a segment, so we need a segment, and we need some point, right? So here's our point out here. So let's see, C, A, and B again. And if it's true that C to A is the same distance as C to B, then point C is on the perpendicular bisector. So we'll make this a point D. And when you see a point that's equidistant from the endpoints, that implies that AB, segment AB, is perpendicular to segment CD, and AD, segment AD, is congruent to segment DB. Okay, and that's because this is the perpendicular part, this is the bisector part. So you see a point that's an equidistance from the endpoints, then that point is on the perpendicular bisector, whether it's drawn there or not. All right, quick vocabulary word. There is something in geometry called a circumcenter. And real quickly, it is the center of a triangle's circumscribed circle. And I'll draw a picture of what that means here to make it a little more clear. So this is what a circumscribed circle means. Circumscribed means outside. There's a lot of interesting stuff about this picture, but all we're going to worry about right now is vocabulary. So we'll make this point A, point B, and point C, and right in the center we're going to have point P. P is the center of circle. This is how you write circle. Circle with a little dot in it. Circle P. Okay, P is the circumcenter of triangle A, B, C. So immediately following our new word, circumcenter, we're going to, of course, have a circumcenter theorem. And it says that, and it's a doozy, the perpendicular bisectors of a triangle intersect at a point called the circumcenter. That is equidistant from the vertices of the triangle. Okay, so that's a lot of words. What that means, we draw a triangle, and we're going to label it ABC, and we're going to go ahead and put the circumcenter in it. But before we do that, so it says that the perpendicular bisectors of a triangle intersect at a point called the circumcenter. So the perpendicular bisectors means of each side. So I'm going to come here and find the midpoint. And so that's going to be one perpendicular bisector. It's going to start from there. And it's going to go this way. I'm not sure how far, but I'm going to go ahead and mark that it's perpendicular. And then I'm going to have another perpendicular bisector on side AC, so I'm going to go halfway to my midpoint. And I'm going to mark that side, and I'm going to go perpendicular from there. Again, I'm not sure how far, so I'm going to kind of stop for a second just so you can get an idea on your picture. And then I'm going to come over here, find the center. So bisector. And I'm going to go perpendicular from there. And so the idea is that these perpendicular bisectors all meet at this same point, and it's point P. the circumcenter, and we would say P is the circumcenter. But there's a lot more going on in this picture too. We have a new point here, so this is D, this is E, and this is F. So when you see this picture like this, right, it said the perpendicular bisectors of a triangle intersect at a point called the circumcenter. So that's what happened. That is equidistant from the vertices of the triangle. Well, that means that this point is equidistant to the vertices. So if we're writing that down, we would say that PA is equal to PB is also equal to PC, right? Or we could say that segment PA is congruent to segment PB is congruent to segment PC. Okay, so that's the idea. The distance from P to A, P to B, and P to C is the same from the circumcenter. All right, so we're going to move on to a different type of bisector now, an angle bisector, which you're familiar with. So we're going to jump straight to our angle bisector theorem. And it says that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So we're going to draw a quick angle bisector. So here is our angle. And like always, this will be angle A, B, C. And we're going to try to split it right into two equal parts. Now I may not have hit it just right, but you get the idea. So this will be ray BD. So whenever you see this, angle bisector means that these two angles are the same. Whenever you see that, that means that the distance from this point to the sides is the same distance. But remember, when we talked about measuring distances from points to lines, we said it had to be the perpendicular distance, right? So when we put our point D on here, that doesn't mean we just go, oh, well, those aren't the same. That's not what it means when it's talking about distance. It means that you go from that point perpendicular to the side. Of course, my picture's not accurate, not to scale, but that's the distance that we're looking at. Okay, that distance is the same. And if this were triangle ABC again, we would say that AD equals DC. And you know, for almost every theorem that we've got a converse for it, so there's a converse. And the converse is going to say if a point is equidistant from the sides of an angle, then it is on the bisector of the angle. So we're going to start out with our angle. So it says if a point is equidistant from the sides of an angle. So that means there is some point and it is the same distance, or if it's distance, it has to be perpendicular. So it's the same distance. So there's some point P that is the same distance from AB as it is to BC. And what that means is, up here, if a point is equidistant from the sides of an angle, then it's on the angle bisector. So what that means is BP, ray BP, is the angle bisector. And what it also means is that angle ABP is congruent to angle PBC. And we can go ahead and add that in the middle here, try to save time and make your picture more user-friendly. But these two angles are the same. All right, we're on to the last little bit. We got one more definition, an incenter. Okay, we just did circumcenter, now we have incenter. That's the center of a triangle's inscribed circle. So this is kind of what that looks like. There is a circle inside the triangle. So triangle A, B, C, and we have our center of our circle P. So P, again, is the center of circle P. P is the incenter of triangle ABC. So we're going to write down our incenter theorem and we are going to be done. The angle bisectors of a triangle intersect at a point called the incenter. That is equidistant from the sides of the triangle. So we'll start out with our triangle. We have triangle A, B, C. And we said that the angle bisectors, so we want to think about splitting this angle exactly in half, and then splitting angle B exactly in half, and splitting angle C exactly in half. And so the idea is that they all come together in this one point. And we need to mark these so we know they're angle bisectors. So these two angles are the same, these two angles are the same, and these two angles are the same. So when you see this in a problem or you see this happening, what we take away from this, if you see the angle bisectors intersecting, is that the distance from the point of intersection to the sides, now remember, this is a perpendicular distance. This distance is the same in all three directions. So that's the same, that's the same, that's the same. So D, E, F, and we would say that PD is equal to PE is equal to PF. Or you could say PD is congruent to PE, and that's congruent to PF. So remember, everything in this class equal to something or adds up to 180. This is going to be an example today of things that are equal to each other. So thanks and have a great day.